let me introduce first my company. My company is an engineering company that is specialized in open BIM. We are offering services for public and private companies at the national level. So our mission is to use the industry-leading technology tools and resources to constantly seeking a more efficient way to use the latest open BIM technologies, especially in the entire life cycle of the building. So with this scope, we do a lot of services like a construction supervisor or a consultancy, of course, design and planning. So let's go back to the project of Naples Central Station. What you are looking at is just a video that show you what we have done. So this is the model of Naples Central Station is inserting Google Earth, and as you can see, this is just a dynamic rendering that is extracted directly from the IFC federated models. So the scope of this video is just to show you how big was the project. So the project is composed by 5 buildings and also the infrastructures that reach the buildings. The station is one of the largest stations that we have in Italy, and is the main station that we have in south of Italy, and more than 150,000 people flew from the station daily, and more than 480 trains transit on the station. So the scope of the project was to apply to the rest of the main Italian train station the goals that we had. The goals we had, the main goals, the primary goals were the method for the generation and maintain up to date the asset information model, not just of this station, like I told you before, but also of the rest of the Italian station. You have to consider that RFI has more than 2,600 stations in Italy. And so to better understand the critical issue and solution for deal with the CDE and management with it, and then apply to the facility property, the security and safety, and manage directly from the CDE, this kind of stuff. Then, of course, there are another primary goals and some more secondary goals. So one of that was, for example, to better understand how to up-to-date the survey, and so how to up-to-date the model and how to align the management system and the model. So the first thing that we did was to identify the BIM uses. So we had the analysis and recognizing of the existing condition and rebuilding the existing condition virtually. And then we had also to deal with the management system, and then also to manage the asset, like I told you before. So just to better understand, what you are looking at is the main point cloud of the station that we have surveyed. As you can see, the the total of the model is really large, is something like 40 hectares. So as you can imagine, we had a lot of issue, a lot of trouble to looking at and to effort during the process. So the survey data, we did it by drone and by laser scan. We could define a point cloud, and then with the orbital picture, we could be able to have the real situation as it is. So we used software like TrueView of Leica, or like another Italian software that is Smart City 3D, to work with the point cloud. Then the other okay, then we had to model the station, but before we had to deal with the point cloud. So deal with the point cloud, it's really complicated when the point cloud is so big, because there is a dispersion of the information, and you have to deal with the big point cloud. This dispersion of information is showed in this situation. So the point cloud is made from consecutive scans, and when you scan and put together, when you scan something, you have to think about that in one scan you can acquire also points that are really far away from where you are. So you have to assemble everything together. So the result is an enormous point cloud that is really difficult to deal with. So we decide with the client to partition the point cloud with a criteria that we define with them. And so we cut these portions. So in the future, we can substitute one portion when something is changed, something important is changed. So also, these portions are easy to manage during the modeling phase. So I'll go ahead. The next step was the classification analysis. So we study the assets encoding mode that the client has. The client has a really great experience in the field that started 200 years ago. So we had a lot of work to do with them, and then we identified the main IFC classes, and then we defined the hierarchy of the systems. So next step was to define the reference data library. Every equipment, every element, we did the model. Also the model, we insert the information, we classified the information in the types of elements, and in an IFC way. So every element has its own p-sets of attributes that are necessary for the maintenance during the life cycle of the elements. These elements then are inserted in the specific position where they are, and I'll show you later how many they were and they are. So then we acquired from the client the documentation. As you can imagine, the documentation was largely disorganized because the station has been working since many years. So we took the data sheet, we took the survey data that we did, and then the architectural and also the equipment and the MEP as-built layout. So we arranged them in organized classification, so we could be able later to insert it inside the CDE. The CDE in the phase of the project information model is the same when you are designing something and then constructing something, than when you are surviving something that already exists. So the difference is to have at the end an as-built or to have an as-is that we acquired. So as you know, the typical CDE, they have a work in progress where the designers, the modelers, shared through a BIM cloud authoring program, more of one, the federated models and the documents, and then we started to work with the client together. They asked us to modify something, and so in the share area we shared the documentation and the models, and at the end, after the approval phase, we published the model. So at the end, we had a really big federated models, and also the point cloud, and also all the equipments that has to be maintained. They are more than 12,500 that we have identified and insert in the model. So we did a flexible file structure. The result of this flexible file structure is a lot of federated models for discipline, for areas, for maintenance systems, and the union of them is the model that you have seen at the beginning. The result was 44 structural models for the implementation of the BIM uses that we define. And, okay, there is something that is jumped, but we did it in everything with the Open BIM. I don't know, because Open isn't shown there. But we did it with the Open BIM. This is the result. What you are looking at is the model inside Solibri. So this is the federated model of all the models is, as you can see, in IFC. You can do whatever you want. You can query the model. You can look at something. You can look at every equipment that has to be maintained, and also at other properties of the model. Okay. Just to make you understand how was hard the activity and how is hard the activity of modeling. This is a portion of point cloud that a modeler is using to model a curtain wall, for example. In this case, as you can see, the modeler is able to insert in the right position the curtain wall, and every frame of the curtain wall can be put in the right position and is overlaid to the point cloud, so we can be sure about what we are modeling. So the as-is of what we surveyed and what we model is absolutely certain. So the equipments. Then we insert all the equipments, like I told you, the equipments that have to be maintained. And this is just a view of an example of them. Okay. Now is the tough part. Most of you know the English pass. The English pass has the point from 1 to 6 that are the project information modeling. So if we are designing something, or if we are remodeling something, at the end we have the handover. I don't know if I have, but here there is the handover. So at that moment, at time 0, we have a model, we have a point cloud, so a survey. We have a situation that we have to start to maintain. Everything has to be aligned. The accounting, normally in a larger situation, for the account, everybody use the SIP system. So it's really important in this phase to define which system is the master of a piece of information, and which one is just the slave, which system is writing the information, and which one is reading the information, because the information has to be unique. So we can have, in this situation, major works, maintenance or minor works, or something else that will change the asset. So if something physically changes, the master has to be the model. If when you start, when you modify something that needs a major work, you start a new project and you remodel everything, and then you have to substitute that portion of model that is changed, also the portion of survey that is changed. But when you do a maintenance, maybe that something small is changed, and you have to update the model. That's the problem. So we are in this situation, and we can have many maintenance process during the life cycle of the asset that can change the asset. What we did was this. For example, we set the authoring program in a certain way that we are able to extract directly, automatically, some information directly from the model, like the location code that is the position of the element in a specific way. As you can see, we are in the 3D of the authoring program, and the initial location code of this element that is an extinguisher that could be inside a specific area, can be moved in another area. So he has to change his own location code. So as you can see, automatically the authoring model, also in 2D and in 3D, changes automatically the location code. So this means that SAP, if in SAP there is another position, they has to be reconciliated. So this process is strongly important, because we can recognize, we can virtuously realign all the systems. So now we are in the 6D, in the facility management. We have to deal with our asset, and we have to maintain up to date, as I told you, the system. But also we have to be able to query it, to visualize it, to apply a model management. So as you can see, there is a part in this. We modified the CDE, so the CDE is able to show the element, but also to bear the maintenance. So we in this case we have a process that is the programmed maintenance, the scheduled maintenance. So in the scheduled maintenance, you have a checklist that you have to fill on file, or you can create, the owner can create, the client can create his own checklist and ask to the facility service to fill it. Also, we have some job require, and in this case we have to control the maintenance activities. Also, we have to deal with the technical documentation of every equipment that has to be up to date, update at the new situation. Okay. So in this video, you can see the BIM Explorer that is able inside the CDE, directly inside the CDE, to show the IFC property of one element, or also the SIP property of the element, because they are joined. And these are the SIP property, and you can filter everything. So you can find an element, or an equipment, or whatever you want, by filtering the property in the inquiry. Everything, the SIP property or the IFC property of the element, or whatever you want. Also the location code, or the area, or the whatever you want. Okay, so and of course everything you can also look at the scheduling jobs, and exporting it in Excel, and filter in every way you need. Next step is the job request. The job request has a procedure that has to be followed. So at the beginning, there is the job request that you look there, and then you can insert the request of job. The request of job can be identified directly in the model, but can also be associated with the specific equipment that has to be maintained. So as you have seen before, you can look directly the element with the Unicode that it has. And then there are many other steps that it depends on the kind of maintenance. The maintenance could be directly do or could have an approval phase. If it have an approval phase, he has to be approved. And after that it is approved, the maintenance service will program, schedule the activity. And so when it schedules the activity, we will follow another procedure to excuse the activity. So this is programmed and on-site by using directly an app on a smartphone or a tablet. It can start the operation of maintenance, and so the controller can control that he or her is maintaining. He can scan the element directly on site. The controller can see that he or her is doing that work at that moment, and then at the same time or later can approve directly the intervent that was done, and put the data of approval, and so insert directly the documentation in the model. So what is really important here is what we have learned with all this work together. As you can see here, there is a CDE. All of this is the CDE, and this is the asset information model. The level of information grow up constantly during the life cycle of the building. The life cycle of the building starts here. So we have, when we survey, scan something, we have to insert inside the asset information model the information that we want. And we have to, we have every time a survey phase. Also, just when we have a land, we have a survey phase. And we have to insert in the asset information model the data. The data has to be inserted by using an authoring program that insert inside the asset information model the federated models of the element that we want, of the model that we want, with the IFC property. Here there is extraction rules. Extraction rules is really important because if you think about the PIM, the project information model, during the design phase or during the construction phase, construction information model is a phase of the project information model, we have a lot of information that probably we don't need to conserve so detailed to maintain the asset. I probably don't need to have the specific information of some phase, but I need just to have it to apply some business intelligence analysis. So, and the same is in the as-built. So when you have the extraction rules, you define what you have to insert in the asset information model and the way the information are related. Then, when in the maintenance phase, that is this phase, start a situation that will change in a major work that will change, for example, the building. So you have to start a new project information model. If you do a small maintenance, a small element, you have to be able to change directly through the IFC the model. So what we discovered was that the IFC models is the heart of the entire system. So I finished. Grazie. Thank you.